If I was going to graph like y equals 2x minus 1, what would that graph look like?
You go down.
Right, it'd be a line, right? You start down 1, you go up 2 over 1, so it'd just be a line that's going up from left to right. What would happen if I put a negative on the front of that? The slope would go down, so it'd be falling from left to right. Okay, what if I was graphing like y equals something like that? What will that graph look like? What shape would the graph take? Parabola, right? Would the parabola be going up or down? Up. How did we know whether it was going to go up or down? Right. The first term is positive, so it's going to go up. So what happens if we put a negative on it? It goes down. Okay, so this one's probably kind of new. So what if I had an x cubed? What does it look like? And I'm just kind of writing random. I'm writing random numbers down over here. Doesn't really matter. What do you think that shape's going to look like?
Would it go, if you squiggle, would it really go down?
Close. So x cubed, if you plug a really big negative and you cube it, it's still negative. So negatives over here are going to be negative if you plug in the negative x. But if you plug in a big positive, it's going to get positive. So what ends up happening is something like this. So yeah, it's kind of a squiggle. And guess what happens if I would put a negative on the front of that? So instead of going from down to up, it would go from up to down. It would just be upside down. Okay, let me go over here. Alright. What do you think would happen if we did next to the fourth? Okay. If I plug in a big negative to x to the fourth, it still comes out positive. So it'll be positive over here. What happens though is it kind of, if I plug in a big positive, it'd be positive. So it kind of makes a W shape. So what would a negative x to the fourth look like? Yeah, down, down. So it's more like an M. And okay, let's keep going. How about x to the fifth? Blah blah blah. Any guesses?
Do the same thing as above, but it would go one down. It would go opposite.
Okay, and then of course it'd flip upside down. So it's going from down to up, and then y to the, we'll stop on this one. X to the 6, kind of like a double W. So it's going up to up. And if I make it negative, down to down. Okay, so do you guys see a pattern in these? What's a pattern? Does anybody notice anything?
Every time the exponent goes up, it adds a squiggle.
It adds a turn. Yeah, anything else?
If it's an odd number, it'll be opposite.
Yes. Okay. So if the largest power is odd, which they call the largest power, they call that the degree. If the degree is odd, she said it's opposite. So this one went from down to up. Because if you plug a negative into a odd power, it comes out negative. But if you plug a positive in, it comes out positive. But if you plug a negative into a even power, it's still positive. Positive. So yeah, she said odd degrees they switch from either down to up or up to down, depending on whether the front term, the book calls it the leading coefficient, depending on whether the leading coefficient is positive or negative. If it's positive, it's going up. If it's negative, it's going down. But if it's an even power, it's either going to go up and up, or if it's negative in front, it's going to go down and down. Yeah, so something I didn't mention, this is kind of important. Each of these places where it crosses the x-axis, those points, like if this is like 3 or 3, 0 or something, that's a 0 of the function. That's if the x equals 3, that makes the whole function equal 0. The x-intercepts are also the zeros of the function, or you could say they're the roots of the function. So remember we said, like, if it's x cubed, it should have 3 zeros to the function normally. So that would be these 3. And it's also where it happens to cross the x-axis. Now, the graph could look something like this, and it only crosses the x-axis once. It still has 3 roots, but the 2 roots over here would actually be, it would just have 2 imaginary roots, right? If it doesn't touch the second and third time, that just means there's 2 imaginary roots and only 1 real root. So, yeah. So if we go like to this x to the 4th, it could have up to 4 roots, 4 real roots. But if the w was like floating up here, it would have 0 real roots. And there's other special cases, like if it had a couple double roots, it would just barely touch the line twice. There's only 2 touches. So anyway, those places where it crosses the x-axis, the x-intercepts, are also the zeros of the function. It's what makes the function equal 0. Because if it's like 4, 0, it means when x is 4, the function equals 0. Alright. Anyway, I think we talked that to death. So, on page 276, number 1, it says, for each function, state the degree of the polynomial, the leading coefficient, and the function's end behavior. Let's zoom back out. Maybe I can... let's try this. Okay, on number 1, what is the degree of the function? 4. 4. The degree is just the largest power. It tells us kind of, you know, what the shape's going to be. What is the leading coefficient on number 1? -1. Okay, do you guys remember what the x to the 4th shape looked like? But the leading coefficient's negative, so it's more like an n. So what is the end behavior going to look like? It's going to be going down on both ends. So it's down, down. Even if you didn't know what the picture looked like, you could tell, because if it's an even power, it's either going to be up, up, or down, down. If it's an even degree, it's going to be up, up, or down, down. Number 3, what is the degree of the function? What is the leading coefficient? Okay. 5 is an odd degree. So how do odd degrees work? They either start down going up, or they start up going down. Since the leading coefficient is negative, it's going to be the upside down version. It's going to start up going down. So the end behavior is up, down. It's this, like that one right there. is, oh yeah. So on this one, on 5, they have it like all factored out, spread apart. But if we kept foiling it and multiplying it all together, the leading coefficient would be what we'd get when we, or the leading term would be what we'd get when we multiplied all those x terms together. So if you did like x times 3x cubed times x, that would be what? 3x to the 6th. Okay, so that would, if we FOILed all that stuff together, you don't have to do that, but if we did, that would be the first term with all those x's multiplied together. So what is the degree of the polynomial? 6. What is the leading coefficient? 3. What is the end behavior? Okay, an even degree means up, or down. Since it's positive, it's up.
How did you get the x to the 6?
I said if we multiplied all those parentheses together, eventually all those x's would get multiplied together. All those x terms would multiply to 3x to the 6th. So on number 6, x minus 8, that one is squared. You could actually multiply all that together. It's just more work than you need. So that on the x minus 8 squared, you'd have to do like x times x for the first part of the FOIL. And then eventually you'd have to multiply that by negative x. So on 6, the leading coefficient would, or the leading term would be x times negative x, which would be what? So that would be the largest, the first term. All right. Number 7. For each graph, state the number of real zeros. Okay, so I said earlier that the zeros of the function, or the roots of the function, are like the x-intercepts of the function. So you can tell how many zeros, real zeros, there are by how many times it crosses the x-axis. The function's end behavior and whether the function's degree is even or odd. So the first question on number 7, how many real zeros does the function have? 3, because it crosses the x-axis 3 times. So that implies it could have more roots, but they would be imaginary. But there are 3 real roots. Okay, second question is what's the function's end behavior? I don't know why they asked it, because you can just look at the picture and tell. But
It starts up, goes
just up, down. Okay, and does the function's degree have to be even or odd? If it starts up and ends up going down, that would have to be odd. Odds alternate up, down, up. Okay. Number 9. How many real zeros does number 9 have? How many times does it cross the x-axis?
4.
Okay, and what's the end behavior?
Down.
Like somebody's doing karaoke.
Slow down.
Poorly. No, it's coming from this direction and it doesn't sound very good.
It's always deep.
Last year, David had a study hall, like like over here, like after lunch. And I walked out of the room once, and I looked in there, and he was standing in front of the whiteboard doing this.
He has like 4 study halls.
He has 3. And he has to stay here because he doesn't have a driver's license.
He doesn't have a driver.
No. Or a car. He has to stay here through all 3.
He has to stay there, sitting
How
here.
old is he?
He's a senior, 17 or 18. All right. What are we doing? Oh yeah. So is this since it goes down, does that have to be an even or an odd degree?
Stop.
Wait, why is it?
Even powers always go up, up, or down, down on their end behavior. All right. Number 11. Solve p of x equals 0. So we're finding the zeros of the function. It says actually find all real zeros of the function. So the imaginaries, if we get any imaginaries, we're going to throw them out. Of each polynomial function. Approximate irrational zeros to the nearest hundredth. What's irrational mean?
That's
Like a square root answer. Okay, so we're going to turn those into decimals rounded to the hundredths place if we get any of these. The reason why is because if you have to graph one of these things, and you know it's supposed to be a square root of 7, or square root of 7, well, you turn it into a decimal to find out. That's why. We're not really graphing 13 through 16, or 11 through 16. We are graphing 19 and 20 though.
No.
Yeah, we're kind of behind it, but by okay, so on 11 we're finding the zeros of the function x cubed plus 7x squared plus 10x equals 0. Any ideas for starters? Hush. Any ideas to start off?
Abby's gone.
And Sam.
specifically after it.
Synthetic division.
Okay,
At least he gets.
something. It wasn't a bad guess. Something's unique about this one.
Divide by x.
You take an x out.
Why didn't you say that earlier? Stupid.
I didn't think of it earlier.
Okay, if x comes out, what's one of the answers?
0.
0. Now, we could have done like, what are the factors of the last coefficient or what are the factors of the first coefficient? You plugged them in. But yeah, if x comes out, you need to do that. This thing in here is just quadratic, so it probably factors, right, with quadratic form, or quadratic factoring. So what goes into 10 that adds up to 7?
2 and 5.
So what x values make that equal to 0?
-2 and -5.
So those would be the 3 real zeros of the function. Those are also the 3 points where it would cross the x-axis, but we're not graphing, so but we will later. 13.
Should we assignment?
13, x cubed minus 7x. We're setting it equal to 0. So what should we do first on this one?
could divide by x.
You take an x out. We're not really dividing by x because you don't want to get rid of it, but taking it out
X out, yeah.
is kind of like division.
We probably could do the thing where you do like.
Okay, we need x squared minus 7 equals 0, right? So what do I do?
You could do synthetic division.
What? Just add a
Are
seven.
you
Oh my
Add a
god.
seven over.
Add
Yeah.
the 7 over.
If you want the easy way, you can do that, but you could have done synthetic division. Yeah.
How did that help us?
I'm so glad I didn't say anything.
Yeah.
Hey, you feel stupid.
Square root.
Square root. So what is it?
What's the answer, Jerry?
Alright, so it's fair.
What is it, Katie?
What?
Plus or minus square root of 7.
I was gonna say that.
Okay.
Oh, I know.
However,
My bad.
the directions were change irrational answers into decimals rounded to the hundredths place. So
I forgot how to tell this
rounded to the hundredths place.
2.6.
Mm. Okay, what am I missing?
0.
Yeah, remember we took an x out, so there's 0 is also an answer.
What do you do if you can't take a zero? Or an X out?
So on number 12, you could use, and we're about to,
You just.
on 12, you could use the method we used on the last two assignments, factors of 5 over factors of 1, possible answers. And once you get one answer, you kind of divide it out to find the last two answers. Something called grouping also works, but you guys probably don't remember how we did that, so. Yeah, anyways, 15. X4 plus 4. Let me talk about 16 here a second. Any ideas for this one?
Oh, you can FOIL it.
Okay, it factors. It's not a quadratic equation, but it is in quadratic form. Because it goes x4, x2. So what goes next to the fourth? What goes into negative 12? That would also add up to 4.
Negative 2 and 6.
Negative 2 and 6. And then, alright. So we need x squared minus 2 to equal 0. Or we need x squared plus 6 to equal 0. So what do I do?
Add 2.
Plus 2. Square root, right? Plus or minus square root of 2. Can't leave this, what's this as a decimal? Okay, on this one, if you subtract the 6, you get negative 6. So if you square root that, you get I squared of 6. Now, that's an imaginary answer, so not a real answer, so we're not actually going to use that. Basically because it's not a graphable answer, so they just want this answer, these two answers. Okay, on 17. Okay, it says which of the following describes the end behavior of an odd degree polynomial function with a negative leading coefficient. So if it's an odd degree and the front number is negative, what's the end behavior going to be?
When you say we talk about 6, are you talking about 16?
17.
I thought you said we were talking about 16.
Okay, so remember like odd degree would be like x cubed. Remember it was like this? But if the front is negative, if the leading coefficient is negative, it's up to down. It's going to be descending. So the answer is up down, which is option what? C. Okay, on 18 it says write 3 statements equivalent to the graph of y equals p of x has an x-intercept of a0. So if its x-intercept is a0, then what else do I know? Okay, where it crosses the a-axis, that's the 0 of the function. A makes the function equal to 0. So a is a 0 of the function. And this is kind of like yesterday's question. And I also know that x minus a is a what? Factor.
Is there not 3 statements?
I thought I had read a third one.
Does it say 3 or 2?
Three.
Oh,
This is really just blank on this one.
yeah. They said p of a equals 0 was the other one they said.
P of A equals 0.
Dang it.
Okay, on 19, actually, why don't you guys do a couple equals on pass on. Action. Alright, so 19 says, sketch a graph of each function using its zeros, y-intercept, at least one point between the x-intercepts. So I'm not going to do that part. But we will find the zeros and the y-intercepts. We'll do that. The zeros of the function. What x values make this equal to 0? Whatever x values make that equal to 0, if it was like 2, 0 or something, if the x value of 2 makes it equal to 0. This is an x-intercept also. So we're finding where it crosses the x-axis when we do this. Okay. How can I solve this? It's x cubed. I can't take an x out. It's not factorable. So, kind of, yes. We use rational root theorem. Factors of 6 over factors of 1. And we're going to see what goes into 6, what goes into 1. So it's 1 over 1, 2 over 1, 3 over 1, 6 over 1. Or plus or minus 1, 2, 3, and 6. These are possible answers. How do I see if they're actual answers or not?
You just try out.
Plug it in. So I'm going to try plugging in 1. I kind of remember this from last class, so I'm not really doing this. 1 plus 2 minus 5 minus 6. 1 doesn't work. If I plug in negative 1, that'd be negative 1, plus 2 is positive 1, plus 5 is 6, minus 6 is 0. Looks like negative 1 is going to work. So I'm going to use synthetic division to kind of show that negative 1 works. Should come out as 0 over here. And also to kind of divide out negative 1 as an answer. It kind of does two things at once. If I did it right, this should come out as 0. So add down, multiply up, so negative 1 is a solution, and my last two solutions are right here, inside this. So I could use factoring. Does it factor or quadratic formula? Does this factor? What multiplies into negative 6 that adds up to 1?
Negative 2 and 3.
What x values make this equal to 0?
3 and 2.
No. Oh yeah, you said that. Yes. And then negative 1 was also an answer. Okay, those are the three values that make the function 0. Those are the three x values that make the function 0. So that's where it's going to cross the x-axis. So I guess I'll give you a visual to show you what I mean. So I know the graph is going to cross at 2, negative 3, and negative 1. It's going to cross the x-axis right there. Okay, the other thing that we want to do is find the y-intercept. You guys know how we can find the y-intercept? The y-intercept always, always, always has an x value of 0. Wherever it is, the x value's got to be 0. So to find the y-intercept, you just put in 0 for x. So if I put in 0 for x here, what would I get? 0, 0, 0, minus 6. So if I put in 0 for x, I get negative 6 for y. So 0, negative 6 is the y-intercept. So our graph needs to be able to go down to 0, negative 6. 2, 3, 4, 5, 6. is a cubic function, an x cubed function. So what shape, you guys remember the shape that I drew for those earlier? Like, what did a positive cubic function look like? Kind of a squiggly down up. It's positive, so it's gonna go something like that. So we just need to make one that kind of hits all these points. And that's it's kind of a rough sketch of what this should look like, something like that.
That is so pretty.
Beautiful. We'll talk a little bit about this one tomorrow, but I'm not going to give you guys a lot of time to work on this one.